Alright, so this exercise is going to be the last one that you have to watch before class, and this will be the one that I check in class to give everyone points for lecture notes to help out that knowledge check score if we need it. So, I'll put a big ass star here because this is our first time talking about it, but this is going to be our warm and fuzzy for the next exam. It's going to be this 5-step hypothesis test. And the nice thing is I will have all the steps written out for you just like they're written out here. Now, the only thing I would say about the one on the test is it could either come from this, it could be from part 6 or part 7. So you do want to, we will have both of these. So this is not necessarily exactly like this question, but I want you guys to take a moment, pause the video. We've gone through all these steps. See how far you can go, maybe at least set up steps 1 and 2, and then watch the video, come along and check what you've done. So working through this one, we have a reported proportion of traffic deaths, which was 40.9%. I'm going to leave that as a P for now. It does sound like it's a reported value, so maybe it's a hat, but we'll see what happens. Out of 100 randomly selected deaths, we have our N. 32 were attributable to alcohol. There's our number of successes, right? Our count within that 100. Is there evidence that the true proportion of traffic deaths attributable to alcohol has decreased? So, looks like we have a P, an N, and an X, right? And so generally, just remember, we have something that we're going to have a claim, and then we're going to have some evidence to try to prove that claim. So in this claim, so in this case, our evidence is this N of 100, the sample we took, with 32 being attributable to alcohol. So, you're set up for your null and your alternative. There's only one P that we could possibly be looking at for our null, and that is that P is equal to this value from 2010 of 40.9%. Our alternative still about P, still about 409, and this P right now, just remember, remind yourself, this P is the true proportion of traffic deaths attributable to alcohol in this year, right? That's the big deal here, is that we're changing up what we're talking about in terms of a year. And we do have that keyword of decreased. So our evidence, as we can see, is evidence that we have something less than, because we could even calculate this for a P hat. Alright, so if we want to calculate our test statistic, here's where we just need to realize our test statistic just means a fancy pants way to say our z-score when we're doing hypothesis testing. And this is straight off that formula sheet. So on the formula sheet, we're now doing hypothesis testing. We're doing it for a proportion, right? So that's our formula that we're going to write down on the next page. And again, this would get us some points even if we got stuck on this. So our z-score is equal to p hat minus p naught all over the square root of p naught q naught all over n. So, our p hat is our evidence, right? Our 0.32. I never finished that. And then we're going to subtract off our hypothesized value. So how different was 32% from 40.9%? Seems like a pretty big difference. But that difference really is only matters depending on how wide my standard deviation is, right? So in this case, our standard deviation is going to be based on that 0.409. Q naught is just 1 minus that. And this is all over our sample size of 100. So if we're doing this in a calculator, we want to do this either in 2 steps or using parentheses around that top. I'll just use parentheses. We know what z-scores usually are. They're between -1 and -3 and 3. So if you get out something really different than that, you might have made a mistake. Need a square root. That is not a square root. Square root of 0.409 times 0.591 divided by 100, which is -1.8. So just like in the last example, it does make sense that we have a negative if we're doing a less than. If we really wanted to, we could even draw a picture of what we're dealing with here. We said, what if it's 409? How likely are we to get a 0.32? And then you could actually go on and calculate your standard deviation separately if you wanted to. So the next step would be to calculate your p-value. So again, you could either do a normal CDF, or I'm just going to look up negative 1.81. So if I go back to my table, that was a z-score, so I'm going to go past the t-table, and I'm looking for negative 1.81, 0.0351. 0.0351, so only a 3% chance. And then we're going to make and justify our decision. So here's a spot where on this particular problem, students will miss points because they don't answer the question and do both pieces. So we need to make and justify. So the justification is going to be looking at this and comparing it to our alpha. So how does that p-value compare to your alpha? That's my justification. I can write that in words, or I can just write this. And since my p-value is less than my alpha level, my p-value is low, so I'm going to reject the hoe. And then my conclusion, since we rejected the null, we're going to say at a 5% significance level, there is enough evidence So remember, reject the null is always going to be there is enough to conclude. And then remember, we did this before. You can always do pretty much two different possibilities. One where you write this thing in words, and one where you sort of copy the question. So if we're doing this, we could write this in words. We'd be saying something like, here, I'll do the copying the alternative in words in green. To conclude that the true proportion, that's what P is, right, of traffic deaths attributable to alcohol this year is less than 0.409. That's sort of copying our alternative, right? Less than 0.409. Alternatively, we can look up here. We can usually copy what's in the question stem as long as it matches what's in our alternative. And so in this case, the true proportion of traffic deaths attributed to alcohol has decreased. So it would have been shorter to just say has decreased. The only thing you want to be careful of when you're copying that is that you are matching up with the alternative hypothesis. So hopefully, oh, I want to show you guys one more thing. This whole process, if you have the big calculator, there is a shortcut for it. In the calculator, this is only the big one. 1 prop z test. It won't do all of it for you, but it'll do steps 1 through 3. So if you have the big calculator, if you go to stat, oops, and go over to tests and 1 prop z test, you'll see it asks you for the null value. What is it that we're testing? What was our evidence? We had 32 out of 100. And what is our direction? Here's where students overthink it a lot. This is P and this is the value. So you do want to have it look exactly like it looks here. So in this case, we have a less than symbol. You want to have a less than symbol here. Students always overthink it and want it to, like, I don't know, always overthink it. And then you press calculate. You can see it reinforces your alternative, gives you the z-score of negative 1.81 and the p-value of 0.0351. So if you have the big calculator, you can just copy step 2 and 3 down out of it. Just write that you did 1 prop z test.